It's 3 separate videos. So if you watched the last 2 and then watched this one, I magically turned white, more white. I'm very white to begin with. So let's take a look at this first one, number 1. So we need to decide. I assume we're trying to figure out if it's convergent, or conditionally convergent, or absolutely convergent, or divergent. So easy thing. Let's do the test for conditionally convergent. Just take away that, get rid of that -1. See what the limit of, that's it, right? Yeah, okay. And since we have an alternating series, as long as this goes to 0, which luckily it does, keep in mind, of course, that 1 over ln of n is less than or equal to 1 over ln plus 1. Greater than. Yeah, the one that makes sense and makes the problem work. Okay, so now let's think about absolute convergence. So let's see, if we take 1 over ln of n equals 3 to infinity, does this converge? That's a good question. So at first thought, you think, okay, well, ln kind of looks like this, right? And so, and if we also plot, what is it, n? N looks, what do you think about this? Yeah. Oh, wait. Yeah, okay, we plot n, looks something like that, where this is some number, right? Yeah. Okay, so maybe this this might diverge. So let's go on the assumption that it's gonna diverge. What might we like to compare it to? If we're gonna say use the limit comparison test, limit n goes to infinity of 1 over ln n. Let's compare it to, let's say, if we think it diverges, what's one nice one that we know that diverges? Maybe 1 over n. So 1 over n. So that's the limit. I hope this works. Ln's are always a little weird. Of n over ln. You might be thinking to yourself, I don't know what that is. But that's because you can do L'Hopital. That's fine. You good. You know. You're a good student. Let's see. 1 over, because that's infinity over infinity. That's how we know we can do L'Hopital. N, ln, derivative of ln is 1 over n, I hope. That's the limit. As n goes to infinity of n, which equals infinity. So maybe limit comparison test didn't work here, or maybe we chose the wrong thing. Direct comparison. So let's think about direct comparison. What do we know about 1 over ln? Looking back at our little graph here. So if ln is always smaller than 1 over, or smaller than n, so we have, this kind of shows that ln is less than n. So that means that when we take the reciprocal of both those, it should be greater. And so now we know that limit of 1 over ln of n is greater than sum of 1 over n, going to infinity. I think we're starting at 3 just because ln's are lame. We don't want to go near 0. Oh, 3. And so, but we know this one diverges. And so by the direct comparison test, this one also has to diverge. I've used up the entirety of the board for the first problem. That's not very good. Okay, I've just erased all of our work, but we found out that this did converge, but not absolutely, right? The 1 over ln didn't converge, so this one is conditionally. I'm sure that's probably something like how you spell it, conditionally Convergent. Not important. Spelling's not important. Never has been, never will be. Convergent. For number 1. That's number 1. Keep that in mind. Okay, let's look at number 2 now. Number 2 looks very similar to one we did a couple videos ago. You notice that it's just it's just polynomials, top and bottom. So just look at the leading power of both, and you see that the leading power of the top one is 2 different than the leading power of the bottom polynomial. It's to the second and to the fourth. So maybe you think about dividing by n squared on the top and bottom, and then you see that it's kind of similar to 1 over n squared. So you think, okay, I'll do the comparison test here with n squared. So 2n, or 1 over n squared, I should say. Oh, it's horrible. It's okay, guys. You can read that. Okay. And we're going to compare that with, so push it up to the top, which is equal to the limit as n goes to infinity of 2n to the fourth plus 1. And that, of course, is 2, which is a number that isn't 0 or infinity. So we know that since 1 over n squared, we know that one converges. So that implies that our number 2, 2n squared n to the fourth plus 1, also converges. All right. That was a nice simple one, hopefully. Don't feel bad if it's not. That's why we're here. We're practicing. Practice makes perfect when practiced perfectly. Don't worry about that last part. Okay. So number 3, this is another one of those ones where you might say, okay, a couple videos ago he said there's a power of n, so let's do the root test. But if you remember, that didn't end up working out so well. So maybe we've learned. We've learned because we practice. So now when we're on the test, we're going to see something like this, and we're going to think, maybe it's not the root test. Maybe since there's an n factorial, maybe I should do the ratio test instead. So keep that number 2 all together. Let's go with number 3. And let's think, let's do the the ratio test instead. Because we're practiced. We know what's going on. So we're going to do n plus 1 factorial times 3 over 3 to the n plus 1 times 3 to the n over n factorial. We're going to say, okay, well that's, we're going to cancel out our 3 to the n with the n there, and so we're going to cancel out our n factorial with the factorial there, and we're just going to have n plus 1 is left on the top, and a 3 is left on the bottom. And that equals infinity. Whoa, and what does that tell us with the ratio test? This doesn't converge. Sad day. Right? Yeah, divergent. All good. So from the ratio test, we know that this is divergent. Easy peasy. So number 3, divergent. What do we say about number 2? Convergent. There you go. Easy peasy.